So, first of all, we're still in the optimization section, which is on, how do you find a max or min? How do you know if it's a max or min? Like, what are the things we check for? Obviously, you guys are really good at finding critical points and inflection points, which are based on these, but it's knowing if it's a max or a min. Not just going, okay, I found a critical point, but I don't know if it really is one or not, because you have to do the checks. That's what this section is all about. Now, obviously, one of the questions for us is doing tables. This is one aspect of it. Tables or graphs. So on this table, we have three x's that were provided for us. So x1, x2, x3. They're random numbers. I don't know what they are. They didn't specifically tell me. That might be something we do tomorrow. I give you a specific number. Now, all the slopes at every single one of them are all less than 0. So what does that mean for slope? Negative slope. It's going down, right? It's dropping over all three x's. So it's dropping consistently from the left side to the right side as I go through three x numbers. So that's something we'll get to when we actually go to the graph. Now, the second derivative, this is the concavity, changes. And you're probably thinking, well, how does that even work? It's dropping, but the concavity is changing. It's not going up because the slope is dropping every time. It can change directions. It can flatten out, even though it's not going up. If it flattens out, that changes concavity. Okay, so let's talk about this. So on the first part over here, what does it mean when the second derivative is greater than 0? What type of concavity is it? It's concave up. The second derivative has a positive second derivative, right? It's greater than 0. That means it is concave up. That means it's holding water. The second derivative is above 0. It's holding water in the bowl. Okay? The next one, this is a negative because it's less than 0. So what does that mean for concavity? It's concave down. The next one, it has a positive second derivative. So what kind of concavity? Up. That means it's holding water in the little cup somehow, or like some version of that. And then later on it goes negative again, so it is down. Concave down. Okay, because it's less than 0. So how this works, if you want to see, like, how do I draw a graph that is going down consistently, because the slope is negative, but its concavity is changing as we go through three different x numbers. It was at the very top. They said the slope is less than 0 over all three x's. It's at the very top. This one was a different table. I pulled these directly out of the book. The same with like yesterday. Pulled that one out of the books just so you get to see some. Okay. All right. So let's take a look at this graph. Again, we have three x numbers, and again, I don't know where 0 is, so this is just my graph, right? So here's x1, and again, I'm making where these points are, x2 and x3. Okay, so it's dropping over the whole one. So we know we're starting in the upper right corner and we're going down to the lower right. We know it's doing that. It's dropping, it's going down. Yep. But it's changing concavity as we go. So how it's doing that in this first bend, as we go up to x1, I don't know where it's at. It didn't tell me specifically where it's going to be. It's concave up. So that means it's probably doing something like this. It's probably doing something like that, where the concavity is up, it's holding water in its bowl, right? It's curved upwards. Even though the slope is negative, if you think about this, all the slopes here are negative, it's dropping, right? It's getting towards the point where it's changing, right? Where it's kind of flattening out a little bit. And then, suddenly, it keeps going, because it goes concave down in the next part. So if I go back to that table, it went from concave up to concave down now. So it went concave down. So that means it probably did something like this on this next part. It probably rotated down because now the concavity is downward facing. It's pouring water out of the bowl. If that's like a half of a bowl, if you can see like the edge of the bowl, it's pouring water out the bottom. Question.
Would we ever have to do something like this on like a tangent graph?
Yeah, I mean, that's really kind of the thing, right? You could look at any type of graph, tangent, cosine, sine, and you're trying to figure out where the concavity is, right? It could be like where the inflection point was, where the critical point is, that type of stuff. Yeah, it's a good idea. Like, right? They could ask you just like, state where it goes concave up and concave down. Just give me the boundary. That's like a type of question they would ask. So yeah, and I mean that does look like a tangent graph. It's just a little bit. It's more of a cotangent graph, really. Starting the upper left, going to the down, lower right so far. Okay. Now, what happened at x2? I think it changed concavity again, didn't it? It went concave up. So that means it possibly at this point. So it was kind of dropping, and then at some point it leveled off again and went concave up right at x2, right? So at x2 it suddenly switched to concave up for a little while until it got past x3. So at x2 it stayed concave up now, right? Concave up until it got to x3, where now it's going to go concave down now. After x3. So after x3 it went concave down, and I didn't draw that far enough over here. That after x3 it went concave down, so it went something like this. So then the idea is that the concavity over here is down. Okay.
How did that x to the second x not go up though?
Because it's going downwards, right? So it's dropping right here, so it's going down, and then after x2 it kind of leveled off a little bit. It's still going downwards, but it leveled off. And so what happens if you look at the picture, like ignore all the rest, this bowl is facing upwards, so it's concave up after x2. So it's got concave up. It can hold water in the bowl. And then after x3, the bowl suddenly dropped and went the opposite direction, and it's pouring water out the bottom. So it's after this point, then it curved, it didn't go like level, it just kind of changed directions a little bit. So concave up, down, up, and then down again, and that's what we have. Okay? And again, this is just a rough sketch of what this thing is doing by just looking at, critical points, inflection points, and the table telling me where certain things are and interpreting the data from it. This stuff, I know it's like the second day you're seeing this stuff. It's not easy. That's why I want to do one more day of this. We'll do maybe a table or two tomorrow like this. I'll have you try out a couple.
We gotta do 3 problems just like this.
Okay. Are we good on this so far? I know like on the next test we have, this is one of the questions for sure. It's one of these.
Nice.
Okay.
Do another one, Ward.
Another one of those?
Just once. Continue on whatever. I almost got it. Keep moving.
Just do next one.
Next problem? Okay, all right. All right, next problem. Okay, so this is like the question of the day you're going to have today, like this one. So I'm not going to give you a table today. You're going to get one of the tables tomorrow maybe for the Google question. Today, your question is, if I give you a function, and there's usually a story problem. I didn't give you any story problems today. I just give you the formulas just so we can practice the math portion of it. It says, find the critical point or the max or min. That's really what it's saying. Find the max or min over the certain frame, this certain limit. We're going from -3 up to +1. There might be either a max or min somewhere in there. It's going to be some type. It could be a global, which is an absolute. It could be a relative, or maybe there's a couple hilltops. But we have to find where it's at with some random equation. So there is supposed to be a space between here. I know I didn't draw a lot of space. There's supposed to be a space. So this is the function that we're working with, and this is the spacing that we're working with on the graph. So we're going from -3 up to 1. Okay, does that make sense? Yeah. Now I'm going to show you something I didn't do yesterday because I want to take a little more time today on this stuff. First of all, to figure out critical points, we should probably at first take the first derivative. Let's do that. The first derivative should be easy, especially the one you have in your Google question of the day. It's meant to be simple. I didn't give you any tricky ones today, so that'll be maybe tomorrow. Let's do a first derivative here. What do we have?
4x to the third.
Okay, good. We have a 4x to the third. We have a minus sign, and now what? 16x. There you go. And it would be to the first power, right?
Yeah.
So there's your first derivative. So now we can figure out the critical points from there, potential max and mins. That's what critical points are. Potential max and mins. Now, what I like to do is to figure out this for sure, I set up a little chart, and this is something we didn't do yesterday. This is to help you out. This is a shortcut that I did when I was in Calc 1 as well. So you set up a little table. This is what my math teacher always taught us. Set up, it's not really a table, it's more just like a number line. Okay, so you're setting up a number line. On the number line, for sure, you need to have the boundaries from -3 up to +1. Agreed?
Agreed.
Because that's our limit. We have a limit here from -3 up to +1. Now, in there, we also need to plot any time we'd have a critical point between those two numbers. So now what we have to do is we have to go back to our first derivative and see if we can factor that thing apart and figure out potential critical points. Okay, so if we factor this thing apart over here, we can take out a 4 and an x. I agree with that. That's probably the common factor we have. So we pull that out. That's going to be an x squared minus 4. If I pull that out, and then I can still factor that up even further because that's a difference of squares. So it looks like the complete factoring of this thing is 4x for sure. And then this is a difference of squares, so it's going to be x plus 2 and x minus 2. So it looks like there's 3 other critical points between there. Okay, so the critical points we're going to have, what would represent this one? 0. What would represent this one? 2 and +2. Okay, so between -3 and up to 1, there's actually 3 critical points I have to check where there could be a potential max or min. For which one?
How?
What do you mean how?
Because 2 is
There's
greater
only
than 1.
2 in the middle.
Oh, 2, I mean. 2, yeah. I agree with that. So, yeah. So if you didn't hear what Jamie said, she goes, well, 2's out of the boundary. So we throw that number out, right? Because we're only sticking with between -3 and 1. Sorry, I didn't think of that. So, okay, so we're going from -2, we're going up to 0, and we're going to throw out this one. I'm just going to put, an arrow through it. We don't need to use the number 2. I know it's a critical point, but it's not in the boundary that we're limited to. So we can throw that one out. So that was a good catch.
I just randomly picked one. So
Okay. All right. Are we good so far?
What did you just do?
I factored my first derivative to figure out the potential critical points, and I put them on my number line. But we threw out one of them because it wasn't in the boundary. They limited me between -3 up to 1.
Okay.
So I had to throw out the number 2. It was too high. So.
like whoopsie baby.
Okay, so now what we're going to do next. I know this seems a little tedious. So, okay, all right. The next thing we're going to do is we're going to start plugging in these numbers into my original function. So I'm going to plug these numbers in. So I'm going to plug in -3 into the original function on a calculator, hit enter. I'm going to plug in -2 into the function, hit enter. Plug in a 0 into the function, hit enter. And plug in a 1 into the function and hit enter. And because I want to know what the numbers are. The numbers at these moments on the original graph.
What do we do with the answers to that?
We're going to just write them right above that. So I'll write them as a coordinate so you'll see it. Okay? All right, so I'm going to plug in -3, and I want to know the number that comes out of this thing. And I'm using the original function to do this. So if you have a calculator, does anyone need one?
It's 9 more.
Okay, you need one? Okay. All right.
I need one.
All right. Anyone else need one?
Negative.
Okay.
You see the negative sign in the number line? And then plug it into the function of
Anyone else need one?
underlying green.
Okay.
Which one are you
So
doing?
it's -3.
I'm not going to break it. I just watered it.
With what?
Water.
Okay, fine. You can water this one later. All right.
I'll water it right now.
16.
Just wait till later. Okay. All right. Okay. All right. So if we plugged in -3 into the original function, the x to the 4th minus 8x squared, what number did we come out of that thing? It was probably pretty big.
-153.
-153? Is that true?
Yeah.
Okay.
What was that about?
The reason why we're putting something to the 4th and squared, so I didn't know if there would be negative signs left over. But since the -8's in the middle, so I was a little worried about your negative sign. So 153?
So you have no faith in me?
No, it was the negative sign I was worried about.
It doesn't trust
So.
me. I thought it was 9.
Okay.
Yeah, it's 9.
-159?
No, -3 is just 9. How? I don't think so.
No.
I'll settle this.
Yeah, I'm a genius.
Guys, I'm 50-50 on right now. Let me try it.
Let's see.
Yeah.
Mental math.
I got -9.
Mental math.
That's too big for my brain. All I'm saying is the calculator
Yeah,
don't
why
lie.
could you
I got 9.
Yeah.
How?
Yeah, I did what you did.
I got 9. I got 9.
Tell us how Erica probably just typed in 9. Ah, I got 9!
I didn't.
Oh, no, I was
She actually did it.
I actually did it.
Erica. Ah!
Will you all also don't use your
Just a lot of
I
parentheses.
actually typed it in.
How did you
Oh,
Just
okay.
a lot of parentheses.
You don't.
Okay, there you go.
Oh,
No,
okay.
actually,
They probably didn't use parentheses.
Oh, I didn't use parentheses.
You haven't used
Yeah, you gotta use the parentheses.
Here's you. I got 9.
Okay, all right,
I already did that joke. It's not funny.
all right. Hey, next. Okay, next.
Every time.
Okay, so next I'm gonna type in the -2, hit enter.
Free zone.
I'm getting a -16.
Yep.
So I plugged in -2, I'm getting -16 out of that thing. Okay, I plug in 0, I'm getting 0.
Oh my god, look at that.
Yeah. It's good.
And the next one I plug in 1, and I get a -7.
That is awesome.
Okay,
How much is one of these?
A lot.
I paid 116 for this one.
Ooh.
I know. But I needed it for college, and then I just like to have one because it's just nice to see the graphs. Okay.
Man, that plugs in. That is like
It was on sale for
-3 all the way through
Yeah,
positive.
yeah, he set up a table.
Just
It's a pair of shoes for me to
Okay.
wear.
All right. Okay. Hey. Okay. All right. First of all, on this graph, I can already see that we have a couple points here. So, what I'm going to talk about here, just as an obvious, this is definitely the maximum on this particular graph right now, just because it was hitting +9. It was the highest peak point. This is probably the minimum, absolute minimum on this boundary, right? It's the global minimum, or in this boundary, it's the max or the absolute minimum. Then we have a couple relatives in there. We have a relative max or a min. That's the other two. Now, I'm not going to put relative max or mins over here. The reason why is I don't know the symbols between them. Like, I don't know if that's supposed to be a minimum, like it's a valley, or if this is like, a peak where it's coming back up. That's where you have to check your graphs, and that's why I set this as a table, as a chart. Because what I'm going to do is between these numbers, -3, -2, 0, and 1, I'm going to be plugging in numbers into the first derivative function. So that's the derivative function was the thing I have in blue, because I just want to know what my slopes are doing. If I can see where the slopes are doing, that tells me if it's rising or falling. I can just get a sense for this between each of these numbers, and I can get a sense if that's going up or down or what it's
How
doing.
come -3 turns out to be 9, but -2 turns out to be -16?
Because 2 to the 4th power, 2 to the 4th power is 16, and when you go 2 squared, that's 4 times 8, which is 32. So it's 16 minus 32.
Oh.
Yeah, it just happened to be like on the other one, the front number happened to be too big compared to the back number. So when you get smaller, the back number turns out bigger. So okay, all right, okay. So shh. So what I'm going to do now is I'm going to plug in numbers that are in between, and I'm going to try to use this like pinkish, purplish color. I'm plugging in numbers that are in between here.
Would you call that a magenta?
Yeah, sure. And we're going to plug those numbers in. Whatever numbers I want, I want to plug them into the first derivative because I want to know what the derivative is doing. And really all I care about if it turns out to be positive or negative. That's really all I care about. But I'm going to the first derivative because I want to know what my slope's doing. I'm not looking at the original graph. I don't care about the original graph. I want to know what's happening between each of these numbers. Is it going up or down? That's what slope would tell me. Okay? So if I plugged in, so if I go back to that function, I'm going to go back to the first derivative function, which is 4 times some number to the 3rd power minus 16. I'm going to plug in a number between -3 and -2. I'm going to plug in -2.5.
10, -10.
And plug it to the 3rd power. We subtract 16 and times the -2.5. All right. So what I'm getting is, the number I'm getting here is, I plugged in -2.5. I'm getting a negative number in between there.
Yep.
It's negative 22.5, like you said.
Which one did you plug it into?
I plugged it into my first derivative. So I'm,
The first room.
I did
Yeah.
not plug it in.
and now when I plug in the next number, I'm going to plug a number between 0.
-1.
I'm going to plug a number between 0 and -2, so I'll go the -1 route. In fact, I'm just going to type in -1.5 because I don't want to delete off the 1.5 or the 0.5s on them. So I'm getting a positive number here. When I typed in a number between -2 and 0, and again, I'm using the first derivative graph. So this is the first derivatives.
Now I gotta do one more. 0.5.
And yeah, and the next one, plug in 0.5, so I'll go back to that original function I had typed in. Type in 0.5.
You're
Delete.
talking about the original as in the 4x to the third minus 69?
Yeah. I'm plugging these random numbers I'm picking between there and plugging into that first derivative. And I'm getting a negative.
Four.
What? Oh, sorry. First, I must not have touched my computer in a while.
Oh, it's a street.
Oh, that's New York.
All right. Hopefully that didn't cause any problems. All right. Okay. Shh. So what this is telling me is that for my graph, and again, I don't have a solid graph here, it was at a peak of negative 3.9. It was going down to negative 2.16. It started going back up, and then it started going back down to hit this next part, which is negative 1, negative 7. So it looks like this was an absolute max, or what they call a global max. That was the outside. This was an absolute min. When I hit that negative 16, it hit a relative max at 0, 0.
That's not to scale, is it, Ward?
No, God, no. Obviously, the 16 or the 9 and the 0 are almost level. And then this next point was a relative min.
Oh, that is to exact specifications.
Yeah, definitely not. I mean, 16 and 7 were at the same level down there. So, but now the reason why, we already identified where the max and min was, so I didn't have to worry about knowing if it's global max or min. We already identified that. But just identifying where the max and min were on the next ones made more sense.
So, like, what are we going to have to know on the Google form?
On the Google form, you have to tell me where the critical points are and tell me which one is the global max or min, or if it's a relative max or min.
So basically, we got to do that everything.
Yeah, but you're not showing me the graph. You're just typing in this coordinate is the global max. This coordinate is a min. This coordinate is a maximum. This coordinate is a min.
So like 0, 0 relative min.
Yeah, that's exactly what you tell me. Okay.
Did you shoot the Google form out?
Yeah, already went live. So.
Let's do it.
Just a Google question.
Yeah, Google question of the day. That's all it is.
That's what I said.
Yep. Yes, you may. You got to water my plant first, though. This plant looks really sickly.
Oh, you're good.
Come here, it's so much. Or both of them are dying.
Yeah, I haven't watered them in a month. Just don't spill on the ground. I got to plug in down there. I don't want to electrocute yourself.
How lit would that be though?
All right, that's good.
Wait, or does it
No,
matter
it's
if
not.
like if it says greater than, but there's not a line under it?
So hey, if you didn't hear Jamie, she talked about like the limits didn't allow you to go to the end caps, so you can't use the end caps. So you can't use 1 and 3 in this if there was no bar. So you can only use the numbers between them.
Okay.
So you may not have a max or min on the outsides because you can't use them because there's no bars underneath yours. So. Yeah, if there was bars, you could use the outside. Like on mine, I did have to use the outside number. It ended up being an absolute. But if I wasn't allowed to, this wouldn't have been a relative min because I wouldn't be able to use it. And that wouldn't have been an absolute maximum because I wouldn't be able to use it.
Do you still have to find them though?
Yeah.
Have you ever spat bars?
What? I don't know what that means.
Do you ever spit bars?
I don't know what that means.
You like M&M?
Oh, no.